everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method, part 2. Solve y double dash plus 4y equal to tan square 2x or d square y by dx square plus 4y equal to tan square 2x or d square plus 4 into y equal to tan square 2x using variation of parameters method. So here y dash is nothing but double derivative of y with respect to x, which is nothing but d square y by dx square, right? Or we can write these two equations in operator form, d square plus 4 into y equal to tan square 2x. So we are given three equations which are same. Okay, solution, and we are given a differential equation of order 2. Given differential equation, y double dash plus 4y equal to tan square 2x, or we can write y double dash as d square y by dx square plus 4y equal to tan square 2x. See, y double dash or y2 is nothing but d square y by dx square. We can have the same equation as y2 plus 4y equal to tan square 2x also. Okay, now let's write d square y by dx square using operator d. So we'll get d square y, we can write it as d square y plus 4y equal to tan square 2x. Now take y common from the first two terms, we'll get d square plus 4 into y equal to tan square 2x, which is in operator form. If you consider the given equation as equation 1, you can consider the second one, the operator form, equation in operator form as equation 2, which is in operator form. Say f of d into y equal to some r of x, where f of d equal to d square plus 4 and r of x equals to the RHS part, tan square 2x. Okay, let's now write the homogeneous equation of equation 2. The homogeneous equation of 2 is d square plus 4 into y equal to 0. Consider it as equation number 3. So now we'll find the solution of equation 3, and then using that solution we'll find the solution of equation 1 or 2. Okay, let's see. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square plus 4. Let's replace differential operator by m, so that we'll get f of m equal to m square plus 4, and the auxiliary equation becomes m square plus 4 equals to 0. We need to find roots, so we'll take this 4 to RHS, then we'll get m square equals to minus 4. From this we'll get m equal to plus or minus square root of minus 4. Now we can write minus 4 as minus 1 into 4. Now split the square root, we'll get square root of minus 1 into square root of 4. Since square root of minus 1 is I, so we'll replace square root of minus 1 with I. We'll get plus or minus I into square root of 4 is 2. Therefore, m equal to plus or minus I2. The roots are complex conjugate. We know that when m equal to a plus or minus ib, then the solution of homogeneous will be y equal to e power ax into some constant into cos 2x, bx, plus another constant into sin 2x. In case of a 0, we'll get e power 0 into x, which is e power 0 into c3 cos bx plus c4 sin bx. Here I am writing c1, c3 and c4 instead of c1, c2, because I wanted c1 and c2 to appear in the last solution, general solution. Okay, is equals to, since e power 0 equal to 1, So we'll replace e power 0 by 1. We'll get 1 into c3 cos bx plus c4 sin bx, right? This is equals to c3 cos bx plus c4 sin bx. Now let's write the solution to our homogeneous equation. The solution to homogeneous equation. Equation number 3 is y equal to c3. For b equal to 2, we'll get c3 cos 2x plus c4 sin 2x. So this is the solution of our homogeneous equation, right? Now using this, we'll get the general solution of equation 1 or equation 2. We'll just replace the arbitrary constants with variables a and b, or arbitrary constants or parameters with some functions of x, a and b. Let y equal to a cos 2x plus b sin 2x be the general solution of equation 1 or equation 2. Okay, now we need to find a and b. We'll find a and b using the formula a dash equals to minus v into r of x by uv1 minus vu1, and b dash by u into r of x by uv1 minus vu1. Okay, here we compare y with some c3u plus c4v, or with y equal to au plus bv. I mean, just compare this solution with au plus bv, you'll get u and v, where u is cos 2x and v is sin 2x. See, u cos 2x, v is sin 2x, right? Here a and b, where a and b are functions of x, and u equal to cos 2x, v equal to sin 2x. Okay, and firstly we'll find uv1 minus vu1 because it exists in both the formulae, right? So first we'll find uv1 minus vu1, and later we'll go for a dash and b dash, and then we'll find a, b. Let's find uv1 minus vu1. This is equals to u into v1 is nothing but derivative of v, minus v into u1 is nothing but derivative of u, right? So we have u cos 2x into v1. This is nothing but derivative of v with respect to x minus v into u1, derivative of u with respect to x. This is equals to cos 2x into derivative of sin 2x with respect to x is 2 cos 2x minus sin 2x into derivative of cos 2x with respect to x is minus 2 sin 2x, which is equals to 2 cos square 2x minus into minus plus 2 sin square 2x. If you take 2 common, you'll get 2 times cos square 2x plus sin square 2x, or you can write it as 2 times sin square 2x plus cos square 2x. Since we know that sin square theta plus cos square theta equal to 1, so we'll replace sin square 2x plus cos square 2x by 1 because it is equals to 1. This is equals to 2. Therefore, uv1 minus vu1 equal to 2. Let's now find a dash and b dash. A dash is given by minus v into r of x by u v1 minus vu1, which is equals to minus v is sine 2x into r of x tan square 2x by u v1 minus vu1 is 2, or we can write it as minus 1 by 2 into sine 2x into tan square 2x. Okay, let's replace tan square 2x, since we know that 1 plus tan square theta equal to secant square theta. From this we'll get tan square theta equal to secant square theta minus 1. So let's replace secant square theta, tan square theta with secant square theta minus 1, or we can also replace it with sine square theta by cos square theta also. Okay, so I'm going to prefer the first one. So let me show you in both the cases. If tan square 2x what happens if we use the second one? Since sine square theta plus cos square theta equal to 1, from this we'll get sine square theta equal to 1 minus cos square theta. Then we'll get minus 1 by 2 into sine 2x into, we can replace sine square 2x as 1 minus cos square 2x by cos square 2x, right? This becomes minus 1 by 2 sine 2x into 1 by cos square 2x minus cos square 2x by cos square 2x, which is 1. Is equals to minus 1 by 2 into sine 2x into 1 by cos square 2x is secant square 2x minus 1, right? Which is equals to minus 1 by 2 into sine 2x into secant square 2x minus into minus plus 1 by 2 into sine 2x again. We can write secant square 2x as secant 2x into secant 2x. Plus the second term. Now replace 1 secant 2x with reciprocal of cos 2x, because secant theta equal to reciprocal of cos theta. Okay, into secant 2x plus 1 by 2 sine 2x. This equals to minus 1 by 2 into sine 2x into 1 by cos 2x is sine 2x by cos 2x into secant 2x plus the second term. So you'll get minus 1 by 2 into tan 2x secant 2x. This equals to minus 1 by 2 into tan 2x secant 2x plus 1 by 2 sine 2x. Okay, what happens if we replace tan square 2x with secant square theta minus 1? Let's see that directly. I'm going to replace tan square 2x with secant square 2x minus 1. This becomes minus 1 by 2 into sine 2x into secant square 2x minus into minus plus 1 by 2 sine 2x, right? Is equals to minus 1 by 2 sine 2x into, we can write secant square 2x as secant 2x into secant 2x. The second term remains the same. Now I'll replace 1 secant 2x with reciprocal of cos 2x will get 1 by cos 2x into secant 2x plus 1 by 2 sin 2x. Then a dash equals to minus 1 by 2 into sin 2x into 1 by cos 2x is sin 2x by cos 2x into secant 2x plus 1 by 2 into sin 2x, right, which is equals to minus 1 by 2 sin 2x by cos 2x is tan 2x into secant 2x plus 1 by 2 sin 2x. You'll get the same thing. Okay, so we got a dash now. Therefore a dash equals to minus 1 by 2 tan 2x secant 2x plus 1 by 2 sin 2x. Let's now find b dash. We'll find b dash using u into r of x by u v1 minus vu1. We know that b dash is nothing but derivative of b with respect to x equals to u cos 2x into r of x tan square 2x by u v1 minus vu1, which is 2. Now let's separate the variables by sending dx to RHS. We'll get db equal to 1 by 2 cos 2x tan square 2x into dx. Sorry, here firstly we need to find b dash, right? Let's find b dash. B dash equals to u just cos x into r of x tan square 2x by u v1 minus vu1, which is 2. This is equals to 1 by 2 into cos 2x into tan square 2x. Let's replace tan square 2x with secant square 2x minus 1, since tan square theta 1 plus tan square theta equal to secant square theta. Then tan square theta equal to secant square theta minus 1, or we can replace tan theta or tan square theta with sin square theta by cos square theta. Okay, so I think this will be much easier. Actually both are easy, this one is much easier. So I'll go for secant square theta minus 1. Since tan square theta equal to secant square theta minus 1, then b dash equals to 1 by 2 into, just replace tan square 2x with secant square 2x minus 1. This is equals to 1 by 2 into cos 2x into secant square 2x minus 1 by 2 into cos 2x. Now let's write secant square 2x as secant 2x into secant 2x. This becomes 1 by 2 into cos 2x into secant 2x into secant 2x minus 1 by 2 cos 2x. Let's write 1 cos secant 2x, since secant theta equal to reciprocal of cos theta, so let's replace secant 2x with 1 by cos 2x. Then we'll get 1 by 2 into cos 2x into 1 by cos 2x into secant 2x minus 1 by 2 cos 2x. So here cos 2x gets cancelled, and from this we'll get b dash equal to 1 by 2 secant 2x minus 1 by 2 cos 2x. So these are required b dash, right? So let's see for sin square theta by cos square theta also. I'll just do it. This equals to 1 by 2 into cos 2x into sin square 2x by cos square 2x. If 1 cos 2x gets cancelled, we'll get 1 by 2 into sin square 2x by cos 2x. Since sin square theta plus cos square theta equal to 1, from this we'll get sin square theta equal to 1 minus cos square theta. So let's replace sine square 2x with 1 minus cos square 2x. So we are having two terms in the numerator and one term in the denominator, so we can split this total expression into two terms, and we'll get 1 by 2 into 1 by cos 2x minus cos square 2x by cos 2x, which is equals to 1 by 2 into reciprocal of cos theta is secant theta, so you'll get 1 by cos 2x can be written as secant 2x minus, if 1 cos 2x gets cancelled, you will get cos 2x, which is equals to 1 by 2 secant 2x minus 1 by 2 cos 2x. You'll get the same thing. Okay. Now let's find a using a dash. We have a dash equal to minus 1 by 2 tan 2x secant 2x plus 1 by 2 sin 2x. We know that a dash is derivative of a with respect to x equal to minus 1 by 2 tan 2x secant 2x plus 1 by 2 sin 2x, right? Let's separate the variable by sending dx to RHS. We'll get dA equal to minus 1 by 2 into tan 2x secant 2x plus 1 by 2 sin 2x into dx. Here the variables are separable, so we can perform integration. Then integral dA equal to minus 1 by 2 integral secant 2x tan 2x dx plus 1 by 2 integral sin 2x dx. Since integral secant ax tan ax dx equal to 1 by a secant ax and integral sin ax dx is minus 1 by a cos ax, then the above integral becomes integral dA is a equal to minus 1 by 2 into integral secant 2x tan 2x. For a equal to 2, we'll get 1 by 2 into secant 2x plus 1 by 2 into integral sin 2x dx is minus 1 by 2 cos 2x plus some integral constant say c1. This is equals to minus 1 by 4 secant 2x plus into minus 1 by 4 cos 2x plus c1, right? So we got a. Let's now find b using b dash. We have b dash equals to 1 by 2 secant 2x minus 1 by 2 cos 2x. We can write b dash as derivative of b with respect to x, which is equals to 1 by 2 secant 2x minus 1 by 2 cos 2x. Let's separate the variables by sending dx to RHS. Then we'll get db equal to 1 by 2 secant 2x minus 1 by 2 cos 2x into dx. Here the variables are separable. So let's perform integration. Integral db equal to 1 by 2 secant 2x into dx minus 1 by 2 integral cos 2x dx. Since we know that integral secant ax dx is 1 by a log mod secant ax plus tan ax, and integral cos ax dx is 1 by a sin ax. Then we'll get integral db b equal to 1 by 2 into, for a equal to 2, you'll get 1 by 2 into log mod secant 2x plus tan 2x minus 1 by 2 into, for a equal to 2, you'll get 1 by 2 sin 2x plus some integral constant say c2. Then b equal to 1 by 2 into 1 by 2 into 1 by 2 is 1 by 4 log mod secant 2x plus tan 2x minus 1 by 2 into 1 by 2 is minus 1 by 4 sin 2x plus c2. So we got b from b dash. Now we are having a and b. Let's now write the general solution. The general solution of 1 or 2 is given by y equal to a cos 2x plus b sin 2x. Let's substitute a and b here. We'll get y equal to a minus 1 by 4 secant 2x minus 1 by 4 cos 2x plus c1 into cos 2x plus b 1 by 4 log mod secant 2x plus tan 2x minus 1 by 4 sin 2x plus c2 into sin 2x. This equals to minus 1 by 4 secant 2x cos 2x minus 1 by 4 cos 2x into cos 2x is cos square 2x plus c1 cos 2x plus 1 by 4 into, this term into sin 2x is 1 by 4 sin 2x into log mod secant 2x plus tan 2x minus 1 by 4 sin 2x into sin 2x is sin square 2x plus c2 sin 2x. Now y becomes minus 1 by 4 into, let's replace secant 2x by reciprocal of cos 2x so that cos 2x gets cancelled in the next step into cos 2x minus, now take minus 1 by 4 common from these two terms, will get minus 1 by 4 times sin square 2x plus cos square 2x. Okay, sin square 2x plus cos square 2x plus c1 cos 2x plus c2 sin 2x plus 1 by 4 sin 2x into log mod secant 2x plus tan 2x. This is equals to minus 1 by 4 into here, cos 2x gets cancelled, minus 1 by 4 into, since sin square theta plus cos square theta equal to 1, so this becomes 1, so minus 1 by 4 into 1 plus c1 cos 2x plus c2 sin 2x plus 1 by 4 into sin 2x log mod secant 2x plus tan 2x. This is equals to minus 1 by 4 plus c1 cos 2x plus c2 sin 2x plus 1 by 4 sin 2x into log mod secant 2x plus tan 2x, which is equals to minus 1 by 4 minus 1 by 4 is minus 1 by 4, which is equals to minus 2 by 4, which is equals to minus 1 by 2. Let's replace minus 1 by 4 with minus 1 by 2. You will get minus 1 by 2 plus the remaining terms will be same as it is. Plus c1 cos 2x plus c2 sin 2x plus 1 by 4 sin 2x into log mod secant 2x plus tan 2x, or y equal to c1 cos 2x plus c2 sin 2x plus 1 by 4 sin 2x into log mod secant 2x plus tan 2x minus 1 by 2 is the required solution. So we have seen second way, the solving of the given differential equation using variation of parameters using second way in this video. I hope you will understand. We'll see you in the next video. Until then, bye bye.